So welcome to another Maths with Paddy video where we state an idea or a theorem from mathematics and do an example or two and always try to get it done in less than 5 minutes. Okay. So today we're going to look at more limits in relation to polynomials, limits of polys. Okay, right. Okay. Um, so in particular, we're going to be looking at limits to infinity. So if we have the limit as x approaches infinity of x to the n, okay, this will just be equal to plus infinity. Okay, now this is true for all n is equal to all the natural numbers. So 1, 2, 3, and all the other natural numbers. Okay, so there's another limit if we get as x tends to negative infinity of x to the power of n. Okay, so this will have a piecewise result. Okay, so it will equal plus infinity. Okay, when n is even. Okay, 2, 4, 6. Okay, and it will equal to negative infinity when n is odd. So when n is equal to 1, 3, 5, etc. Okay, so this can be motivated by the graphs. Okay, so think about the graphs are. Okay, so when we have functions like y is equal to x dn, okay, so n is even here, n even. Okay, so it will just look like this. So you might know the shape of a parabola, y is equal to x squared. So that shape generalizes for all even powers of n. Okay, so and then the other situation is when n is odd. Okay, so we have xy graph, and then we'll have function y is equal to x to the n again, but in this case n is odd. Okay, so it'll just look like this. The origin. Okay, so when you can see here when x is tending to negative infinity, basically the y value is increasing to negative infinity as well. Okay, so I'll just get a new slide. Okay, so we'll just talk about one more thing: is limits in general. Okay, as x tends to infinity. So a polynomial, basically the behavior as x tends to infinity is mostly dependent on the highest, the term with the highest degree. Okay, so a polynomial behaves like it's the term, like its term of highest degree. Okay, like its term of highest degree. Okay, so what that means is that the limit as x tends to infinity of some generalized polynomial function like this, c0 plus c1 by x plus lots of other terms all the way up to cn by x to the power of n. Okay, this will just equal the limit as x tends to infinity of the term with the highest power of x, which in this case is cn by x to the power of n. So this is just like a way of more easily computing the limit of some polynomials that you may encounter when you're dealing with x tending to infinity. Okay. And you can also say this works out similarly when we're kind of like going to negative infinity. So going to negative infinity, again, we have a generalized polynomial. So c1x plus blah, 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 plus cn x to the n. Okay, so this is just the exact same. So this is just, except we're dealing with negative infinity. So x is tending to negative infinity, and we just take out the term involving the highest power of x, which is cn x to the n. Okay, so one simple example is that we can have this limit as x tends to infinity of this big polynomial 7x to the 5 minus 4x cubed plus 2x, okay? So that just reduces to the limit as x tends to infinity of the term with the highest power of x, which is just 7x to the 5. We could factor the 7 outside if we wanted, but basically the limit is going to be plus infinity. Okay, so it's just an easier way of computing some limits of some polynomials as x is tending to infinity. That's great. Okay, thanks a million. See you next time.